Hello, parents and students. To get into the Carnegie Learning Mathia software, which we're using this year for math, first you go to our Clever Hub and log in there. When you go to your teacher's homepage, you'll see a big black dot with the letter CL on it. That's the Carnegie Learning Mathia button. Click on that and you'll go to the Mathia program. Things I like about the Mathia program. Well, first of all, I can see all kinds of productivity and activity graphs, and I can see the skills that the student has mastered, skill by skill. Of course, I can see exactly where their progress is, what they've got done, and what they're working on. Any good state-of-the-art math software would tell me exactly what they need help with, and so does this. But an extra level of data that I really like is that I can see the progress of the class and the individual students on the standards and benchmarks of the state of New Mexico to which those questions on the state test are written. And of course, the Carnegie Learning software does track the amount of time that each student has spent on their program. Let's take a look at the software while it's in progress. I'll pretend to be the student. Up first, some nice video.
Patterns are everywhere. You can make a pattern using colors or shapes, but patterns can also be mathematical. For example, 3, 6, 9, 12 is a pattern.
Assignments are called workspaces, and the vocabulary that they'll need for each workspace is on the front page in both English and Spanish.
Legend has it that mathematician Carl Friedrich Gauss was once given this assignment by his elementary school teacher. Add all the whole numbers from 1 to 1,000. What is the sum? This assignment was supposed to keep the young Gauss busy for the rest of the class. But, to the teacher's surprise, Gauss solved it quickly. He did it by first noticing a pattern. The first number and the last number add up to 1001. The second number and the second to last number add up to 1001 also. And this must go on for all the pairs of numbers in the sequence. There are 1,000 numbers in the sequence, so there are 500 pairs of numbers, and each pair has a sum of 1001. We can rewrite the sum like this, using the distributive property. What is the sum? What if there were n numbers? What algebraic expression solves this problem for any number of numbers?
This was easy enough that I could actually do this in my head. Now let's try purposely making a couple of mistakes. I thought a common mistake would be students thinking of multiples of 2, but you see that the software corrects me right there. So maybe we should guess the next one down. But no, the software's giving me another hint there. Okay, I give up. I want a real hint. Now the software will give me a hint on the exact equation. That helps me through this wall right there. That actually helped me get the next 2 answers in a row, as a matter of fact, which makes sense to me now as an equation. Half of all the pairs times the number that you start with plus 1. No, I don't know what these words mean or what kind of graphs they are. Well, let's see, it's going to help me again, but that didn't really help much. What about exponential? No, it tells me why I got that one wrong. I'll try the last one, quadratic, and then say I'm done. The software starts me off with a pretty simple problem on sequences. I can figure this one out. It's just one more than the design number. Okay, right away as a student I saw this, 3s. It's getting 3 times bigger every time. So I thought about multiplying by 3. So I'm going to try to type that in. Whoops, that didn't work. Well, what about, maybe I typed it in wrong. Maybe it was the number I started with to the 3rd power. But no, that wasn't right either. What am I doing wrong? Well, I'm going to reread that question there and try to change it. Oh, I give up. I need a hint. I know. I'll try that thing I saw on the first page. No. Okay, so now the computer is seeing that I'm struggling, and the artificial intelligence is actually going to give me some help based on the answer that I typed in. So I typed in the rest of the formula. As soon as I got it right, it moved on. Now I'm starting to get this pattern. It increases by a factor of 3. Now here, based off the stuff I'd seen so far with the variable of n, I tried n to the 3rd power. This would be a common student mistake. And that didn't work, so let's try 3 to the nth power. What am I not doing? I'm struggling now. Okay, I'm going to give myself a hint. Okay, X number of tellings. There it is. I'm using the wrong variable. And I gave myself another hint because I really was not understanding what I was doing wrong. So I had the idea, it's an exponential function, and it's going by 3s, so it's 3 to the x power, not the nth power. Now that I've got that, this rest of this should be pretty easy. Square the number of months past plus 2. Right there I got to convert from English into math. Good skill. Sweet! And I've completed this module. That's a workspace for you.